Okay, so what is the idea of a limit basically saying? Yeah, and in this unit, limits can be used in different situations, but in this unit, the limit we're talking about is like, what's the y coordinate supposed to be? So if you're looking for a specific x coordinate, what's the y coordinate that appears to correspond with that? So when you look at this worksheet, you can see there's like different parts they're having you do, and they're asking you for different limits for each part. So what does this notation mean right here? Yeah, you're approaching it from the negative or the left side. Okay, so if we look at an x value of 2 and we're looking from the left side, what does the y coordinate look like it's supposed to be? 3, and that's because that's just the left side right there, so 3. Is it actually 3? No, there's a hole right there, but it looks like it should be 3. All right, the limit as x goes to 2 from the right side, 1. I got an email from Target, in case you were wondering what the buzz was. So what's our conclusion about the limit as x goes to 2?
It doesn't exist.
Doesn't exist. What's our reason for that? Two values. Okay. D says the limit as x goes to 0 from the left. 2. The limit as x goes to 0 from the right. 2. The limit as x goes to 0 in general. 2. So anytime you have a graph that's, we would call this continuous because I can trace it with my finger without picking up my finger. Anytime a graph is continuous right there, we're just going to say, yeah, that's the y coordinate. It's actually there. It should be there, but it actually is there. Okay, it doesn't always work out that way, but it happens to look like it's getting close to 2 from the left side and the right side, and so that's our overall conclusion. Okay. All right, looking at number 2, the limit as x goes to 2 from the left. 4, okay. The limit as x goes to 2 from the right.
4.
Okay. So what's our conclusion? The limit as x goes to 2. 4. Yeah, it's 4. Okay, now the difference would be, what if I said f of 2?
1.
That's 1. So the y value that it approaches the limit is 4, but what you actually get when you evaluate it is 1. So this is the y value that looks like it should be there. This is the y value that really shows up. Does that make sense? There's a difference between the two. Okay. How about the 0 ones? So the limit as x goes to 0 from the left
1.
and from the right,
1.
and then overall.
1.
Okay. What about if you plug in f of 0? You get 1. So in that case, the limit and the evaluation happen to equal the same thing. That's a point that truly shows up on the graph. Okay. All right. So number 3, the limit as x goes to 2 from the left.
1.
And from the right.
1.
And the conclusion overall?
1.
Okay. The limit as x goes to 0 from the left.
3.
And from the right.
3.
And overall?
3.
Okay. What about if I said, what is f of 2?
4.
4. Okay. Now, there's one more type of limit that doesn't exist that was not written on your notes. So I want you to put your notes in front of you. And then there was a place where I didn't speak wrong, but I wasn't completely right. And so we're going to fix that. It was like I could either mention it in class today or I could make the whole video. And I was like, I'll mention it in class. So if you look at your notes, it looks like this on the second page, right? So this is example number 2. And on example number 2, I said it does not exist because it's unbound. And technically what we would say here is, yes, it's unbound, but when you have unbound limits like that, they like you to say if it goes to positive infinity or negative infinity. They like you to specify which one. So you're going to say an infinity answer, and then you're going to say unbound. So if you look at this one, as x goes to positive 2, which infinity would that be? Negative infinity. So we're going to put that on there. You could put equals negative infinity and then say technically that doesn't exist because infinity is not a real number. It's a concept.
So erase the does not exist?
You keep the does not exist. You just say, you specify that this particular does not exist is a negative infinity. So it's possible that they both go down. It's possible that they both go up. Those would both be does not exist unbound, but just different types. It's possible that you have one going down and one going up, which is kind of like a combination of two different values and unbound, because you have like a positive infinity and a negative.
So you could say both?
You would, well, by the time you get to the AP exam, they're not as concerned about that, but they do want you to understand the difference between a negative infinity unbound and a positive infinity unbound. Yeah.
I was going to say, if it's on the AP exam and there's an option with negative infinity and an option with does not exist.
They wouldn't differentiate between those two. All right, so the last one that we're going to add, and I would say this one is kind of like a it makes sense, but we're going to point it out and make it more obvious. So we're going to add a fourth one. We're going to say that the fourth type of limit that doesn't exist is if you have an endpoint. And the reason for that is you can't have a left side and a right side if you're at an endpoint. Does that make sense? Mm-hmm. So if we were to draw, we could say, let's do a picture of a square root graph like this. And if I wanted to know the limit as x approaches 0 from the left, I've got nothing, right? So we're going to say does not exist because there's nothing on the left side of that. There is no left side, okay? And the reason for that is that this is an endpoint. Does that make sense? But we could do the limit as x approaches 0 from the right. What would that be? 0. Yeah. So on the sheet that you're working on, there might be limits that don't exist because they're endpoints and it's missing a left side or it's missing a right side, and then you can't make an overall conclusion. Now, if somebody was looking at a graph like this and all they wanted to know was the right side, then you could say something.
So you can't say the limit of x if you don't have both sides?
Yeah, so the limit as x approaches 0 of f of x, we would say does not exist. And that's because the left side wasn't there. So you could make a conclusion about the right side because the right side shows up. But the left side is not there, so you cannot make a conclusion about the left side, and you cannot make an overall conclusion because the left side isn't there. Okay. Does that make sense?
Mm-hmm.
Okay. So let's go ahead and work on this. The answers are all on the board, so as you are working, you can check them. At any point, if you guys are moving forward in the packet and it seems like we flip to the next page and you can see this is kind of like what the calculator screen would look like if you were doing these using a table. If the table is confusing to read, let me know. We can do some together. Okay, so at any point, if we get confused, that's all you got to do is have a few people come talk to me and then I'll do it in front of the whole class. Okay? Sound good? Sure. All right. Ready, go.